We lose one elephant from the planet every 15 minutes. We will lose all elephants in 10 years. It is that statistic that pushed me into action. 15 minutes. The issues we're having around preservation, nature, and what I've learned is that scientists need help and they're running out of time. Project 15 is about building this bridge between the scientific community and the technical community so they can learn what tools we can bring to the table.
The Serengeti is one of the largest parks in Africa at 17,000 square kilometers, yet the Serengeti only has 150 guards. Imagine trying to protect the state of Maryland with 150 rangers. It's impossible. We started on TrailGuard about 4 years ago. It's a sensor put out in the field that can detect poachers and stop them before they kill. The first ones were successful. The problem was that our camera system sent every image, and that drained the battery really fast.
By listening to him, I learned that a solution that I had designed applied, and that was a safety platform called Project Edison. His camera sent events. It was the same as anything we did in a city, and that was my aha moment.
Sarah talks about the idea, and I said, I know how to do it.
We started drawing boundaries and where we could put devices and how that could all be brought up to the cloud for better notification of rangers.
We built Azure as a hyperscale cloud services platform. We're able to provide machine learning, analytics, or reporting all over the world.
Microsoft is really advancing these deep neural network models that are able to identify any species that is of concern to conservation.
We have a truly hybrid platform. I can run the same services that I have in the cloud down at the edge.
Microsoft's been dedicated to environmental sustainability for a long time. We have this culture that says if you can invent a technology solution to that problem, you should do that.
Project 15 can really have a bigger impact with something I already know.
There's a breadth of challenges that need to be solved. There's connectivity, networking, there's devices to be built.
One idea is to use the drone and the AI, and with this solar cells, we can cover big parks in Africa with the self-charging drones.
These are the kind of ideas. There's animal preservation, climate research, water purification.
We are looking for contribution from people with different technologies, skills, experience. Everybody can contribute.
Whatever you are interested in, take 15 minutes just to think about it.
How can the solutions you're developing be reimagined in the pursuit of solving some of the world's most critical challenges? Join Project 15 and bring your ideas to the table.
Please join us.
Join us.
Join us.
Please join us.
Sarah, you're muted. Sarah, you're muted.
Right. What else is new? Hello, 2021. We're still on mute. Anyway, so I don't know about you, but my video lagged a little bit, but I think you get the idea of the project. Hopefully it didn't lag for you. So today I was going to share a little bit of the origin story of Project 15, and then some things that have happened since that video was made, which are pretty exciting and you can find out in the world these days. So let me just get into it, because I think I have about a half an hour, 35 minutes. So I'm Sarah Maston. I am a senior IoT solution architect. I have been doing process architecture and data architecture for about 20 years. And I've worked many places, built many databases. Some of those pictures you saw are from past positions and stuff. So My hobbies include chasing my 9-year-old around to do his homework. Yay, homeschooling. I hope everyone has been safe during this time. Building Lego buildings. I'm a big Lego fan, and keeping up on my science fiction reading, which the pandemic has kept me home so I could. So Project 15 actually starts with my cat, and she passed last a few months ago, but she's a lot older than the pictures would imply on the internet. So her name was Thomas. Her full name was Thomas, who was a girl. And what happened is that I lived in a building in Redmond, which is where Microsoft's headquarters are. And I lived on the top floor of this building, and I saw a lot of smoke one night. And I kind of panicked, and I didn't know what to do. And my brain said, "Oh, let's go run into the building to save the cat." And so I ran into the building, and I ran up all the stairs, and I grabbed the cat and I threw her into the cat carrier, and she didn't know what was going on. And then the bells happened. And then this was now loud and confusing. And we ran downstairs, and about 30 minutes later, the firefighters said that everything was good. We could go back in. Now, the next day, I saw the guy that runs the building, and I said, "What was that? I have never seen such smoke." And he said, I don't know. I don't know why you did that. The fire was out 20 minutes before your bells went off." And I went, "What?" And then he said that the fire was as far away from me as possible. It had happened in a recycling bin with cardboard, and it was out. And what? And then "Oh, I know what happened. I know what happened. The firefighters put a fan, and it blew the smoke across the garage that runs underneath all these buildings." And I kind of freaked out, and I said, "Oh, there's got to be a better way to talk to people who are inside of an emergency." And that became known as Project Edison. And this is Thomas the Fox, who is, Thomas Edison, but also coincidentally the cat's name. And what this was in my POC pitch to get it funded at work was taking a smart bulb, which you see in the corner there, and we'll call this lady Linda. And Linda is on the map. And if something happens, there's a geocoded light bulb in that meeting room, let's say, and there could be an awareness circle. And if you're in the awareness, that means that, hey, you're not in immediate danger, so please don't panic, regardless of what notifications you may get. Or, if you're on Twitter trying to find out what's going on, you just need to go, make good decisions right now. And if it turns red, it means, we kind of have this kind of system. The bell went off, there is a fire, please get out of there, get to safety. And so that became known as Project Edison, and we built it with a partner of ours. And a partner named Insight took it and created this really cool safe schools solution. And so this was announced on April 15th, 2 years ago, about this time, actually, that was out in the world. And so that was pretty cool. At the same time, I met a gentleman named Dr. Eric Dinerstein. And this is a solution around anti-poaching. This is a smart camera trap solution that can see poachers, and you learned about him in the video, and that's Eric. And so what I realized really quickly, learning this use case from him, was that this was just another use case to a safety platform. And I had been talking literally all around the world about safety. I had safe retail, safe factories, safe workplaces, schools, buildings, etc. And how could I not think safe parks or safe animals? It seems really obvious after the fact, but many of you have probably had that happen to them. Oh, why didn't I think of this? So this was the first drawing that I actually drew when I was explaining it to Daisuke, who you saw in the video. And I just said, look at this. This is a population that can't defend itself. It's something or someone you're trying to stop or make less impactful using devices. And then there's a bunch of people that you need to message to get help. And in this case, it's the Rangers. And so I pretty much, ran around Microsoft to people I knew, and there's a cartoon character that you may be familiar with called Chicken Little, and the sky is falling. And so I ran around going, we can help them. I think we can help them accelerate solutioning in scientific projects. And if you could apply Project Edison to anti-poaching, well, what was the real difference from loss prevention of a shirt in a big store and loss prevention of a pangolin in a park? I mean, these are very similar use cases. They just have different challenges. And everyone who's listening right now, we like challenges to solve, right? So that was really the start of my own learning journey in this area. I didn't know anything about conservation besides, I was a big fan of conservation, and I've been on this earth long enough to notice that some things have really changed, and it's not something I'm happy about. So I wanted to help. And so we put up a web page, and we put up, this no longer exists, but this is what it looked like. And we put out that video, and it was a phone. And we hoped that other scientists would see our video and that they would call us, and maybe we could help. And so we did get some phone calls. Like any idea, sometimes it takes a little time. So a few months in, the Zambezi Partners called, and this was a really cool startup that was, looking to build a system to protect an elephant corridor. And so, okay, yep, got it. Interesting. And then the RedPanda Network called, and this is an incredible organization to learn about, where they had some camera traps, and they really wanted to digitally transform what they were doing. And when you think about how we all have specialties, it's someone who's really deep in machine learning, really deep in data science, may not know how to do all the bits and pieces to do that IoT plumbing, to manage their models, etc. So this was exciting because we knew we could help there. And then we got a call from the United Nations Development Program. There's a group called the GEF Small Grants Program, who is implemented by the United Nations Development Program. And this is a really cool, to be honest, I had never heard of this group there. This is an incredible organization that funds all sorts of amazing projects that are all around sustainability, from agriculture to land management to empowering communities. It's just an incredible organization to learn about. Urban sustainability. I mean, it's just, if you're interested, you can go to their website and learn about them. They're really great. So as we started to meet projects, we started taking notes because Daisuke and I now had a scale problem to solve, in the sense that, if one or two people call you, that's fantastic. But if somebody calls and has thousands of projects, well, you have to kind of figure out how you're going to get to scale. And I just was taking notes. So one problem that I saw people encountering is this catch-22. And that's what I was describing around, if you're deep in data and machine learning, you may not know how to get new data from devices. So that's, I know what to do with my data, but how do I get more data? Proof of concept. I made a device, but I don't know how to create a holistic cloud-based solution with that device. That's one. Maybe you're a small fish. You don't know where to go for grants, or maybe you're not in an academic realm. There could be many reasons for this. You're a startup, but nobody's picking up your idea. But if I could just get a little further with my idea, I could get there. This one I call the pit of financial despair. And this was really the first spirit of the Project 15 video, where I firmly believed that folks were, grant money is very limited, in the sense that it's a little different than if you go in to get seed money and you have an app or something, and maybe a robot you made in retail, and somebody's giving you funding to go build that idea out. Grant money as a business model was a little bit different, that I didn't want anybody wasting their grant money reinventing something that already existed. It's just that we hadn't met each other, and that was really the spirit of the first Project 15 video. And then showcase. Maybe somebody is doing an event and they're spending a lot of time working on something, but after the show is over, maybe that project kind of landed on a shelf, or didn't get to go as far as it could, based on many of the problems I've already mentioned. And then there's this idea of getting to scale. And what's really interesting, once we drew out these roadblocks, was that there are slides where, and many of you are from the commercial space, where these are not unique problems. These are the same problems that commercial solution teams have as well. And that's something that in my job at Microsoft, I guess I should have mentioned that, I work with the partner ecosystem to build out global scalable IoT solutions. And so, this was actually, oh, okay, yeah, we know how to do that. So I did mention that we were trying to figure out how to get to scale, because we can't spend all our nights and weekends meeting with folks one-on-one. And about, I don't know, it was about June, maybe it was last May, I went to Daisuke. I said, I have an idea. Why don't we make an open platform and just put it out on GitHub? Because as we were meeting with folks, we were teaching them over and over again how to kind of set up IoT solution, and 1 to 5, 0 to 5, all the steps and things you needed to do. But the reality was, it was really simple for us to do that and then give it to them on GitHub, so that you didn't have to learn everything from scratch. And there's many things when you're setting up a solution that you're only going to do once. And if we could just do that, that would make it go faster. And then people could learn how, you learn in role, where you're pretty much, you have a problem to solve. You have, here's what I learned to do it with. I copied the code and I built out my own use cases. And so we wanted to contribute that way to getting these solutions to go faster. So our goal was that, the whole spirit of Project 15 is, what can you do? What can you contribute? That's what we could contribute. So by doing that, we could just help people if they needed help doing that. The other thing is that opening it up to the realm of the open source community and universities and students and anybody who wanted to contribute could. That was really, a great benefit of this. You just spin it up with a push of the button. I'm not going to go into a demo of that platform, but if you go out, and I can back up, I think, and show you. So the link is at the bottom of this page, and it will bring you to our GitHub page. And when you click deploy on that link there on the screen, you're going to get a deploy to Azure button. And it just launches right into the portal. And within 10 minutes, you will get everything you need, sort of that IoT plumbing for Azure IoT infrastructure spun up for you, and then you can go from there. And so let me just skip ahead. All right, so this is what you get in the non-technical bubbles. So pretty much everything in green, if it's light green, it is fully included in the open platform. If it's dark green, it is something that you are going to customize, but it is there. And then if it's in the blue, that's that 10 to 20% of your different use cases that are going to really make a solution your own. And how Microsoft works when we work out on GitHub and do solutioning like this, and to help accelerate your work, is that once you spin this up into your own accounts, it is yours to go. It really just is to help you move faster. And my colleague Daisuke, he compares it to an instrument. You know how to play music, but it doesn't mean you want to go build the instrument. So this is just an instrument for you to go and then build whatever music you want to play. Here's what it looks like with the more technical. For those of you who are into Azure already, you may recognize many of these icons, but this is essentially what you're getting. Everything in green is spin up and go. Everything in red is some place where you can add on to it. And so I've actually given some talks recently where the minute I start talking, somebody goes and starts spinning it up in the background, and then by the end of the talk, they're like, "Wow, this really did spin up." And I said, "Yes, yeah, it does." Um, so that is the open platform, and I'm going to talk a little more about that in a little while. But I wanted to talk again about scale. So there are so many projects to do, and there are so many wonderful, wonderful organizations doing things. And once you know where to look, you start opening up to, there's many technical communities that combine, scientific developers, technical folks coming together to do this sort of work. And it's getting more and more prevalent. 2 years ago, I was having trouble finding some of them at first, but you meet one person teaches you about the next one, and off you go. We have a program, which is, I'm going to get the IXN, I believe it's called, but it's a capstone program that Microsoft runs in partnerships with many universities that are in the world. And I'm going to highlight one project that we've just produced, a blog post about it. There's all sorts of stuff you can read about it now. And this is with the University College London, where the idea was, this is another one of the what if moments. What if we could take students in these, very, very cool capstone programs where, they're writing their senior project essentially, and pair them with an NGO to help move these projects along. And so we piloted it over the last 6 months. And one of the ones we partnered up was the RedPanda Network. And we partnered them with a student. His name's Farid. And this is what the RedPanda Network really was. A lot of manual processes, just camera traps, generation 1 camera traps. They're not connected, etc. This is what he made. And you can go out to GitHub. I put the link down at the bottom there for you to go explore. This was really, really incredible to watch. And if you think about somebody who's living in a world, where they're doing everything themselves, it's kind of manual. All of a sudden, as you explore this repo, and it's all open sourced, he's putting in, he's got vision in here. He's turning your camera into its own camera trap, so that when you upload a photo from something you've taken from a smartphone, it can now scrape that metadata for you and put it on a map using Azure Maps. And so this is really transformational, especially, if you're new to doing this sort of thing, or you already work with an NGO that you volunteer at or something. This might be a really, really useful tool that you can take and edit and make it for their use case. But this was really incredible. And I just put this one in because red pandas are incredibly cute. And they were discovered before the giant pandas, I learned recently. So actually, if you're into learning about red pandas, they're very, very fascinating creatures. All right. The second thing, and we've landed a few of those, and I can share links after. We just had a great show on Learn TV over at Microsoft where we got to feature the student projects that landed this semester. It's really exciting. Okay, attempt number 2 to get at scale was something I was calling the Project 15 Challenge. And so this was interesting as we piloted it last semester with Oxford. And there's a professor in the continuing education group who said, that sounds like a really cool idea. I'd love to bring it in as a semester project. And you'll say, what is the Project 15 Challenge? I'll say, wait for it. All right. So here's the deal. So this is an NGO named the Elephant Listening Project. They are in Cornell, sitting in Cornell, but I called them and said, hey, I have an idea. How about we bring in a bunch of use cases that you have not been able to solve yet, and we give a background on the topic, and we just throw down the gauntlet to a bunch of smart students studying AI and ML and say, what if you could figure some of these out? Not knowing if it would work. It's a very, it's been a little while since I've been in school, actually, but usually with semester projects, you kind of have like, here's the outline, and you're going to do this, that, and the other thing, and then there's going to be an answer. This was weird in the sense that even a failure would be a success, and there had never been an answer on these use cases. So it was worth a shot. So essentially, the Elephant Listening Project, it does what you think it is, where it's listening to elephants. And I learned about something really interesting with elephants in the sense that they speak to each other. And many of you, I don't like virtual events because I can't say everyone who knows how elephants talk, raise your hand. And so they speak in a band that's called infrasound. And biological males and biological female ears cannot hear it. It's really interesting, and it's a really long wavelength in the sense that it can travel like 5 kilometers through the trees, and they can talk to each other over great distance. And they even have the ability to speak through their feet, and pick it up through their feet. So it's a really interesting topic. I know very, very little about it, compared to someone who studies this, obviously. But the more I learn about it, the more interesting it is. Oh, I should point out, so you see how in this, you see this image here, it seems like there's reverberations. I'm going to say the word wrong, but it's echoing up, and that can be one elephant that's having this echo sort of effect. You see another one next to it, and that's another elephant. And so one of the use cases that was to be solved was, and I thought I put a slide in that showed, but one of the use cases was that they had never been able to count them. They couldn't tell if it was, they could tell if it was one elephant, and they could tell if it was 2 or more. And otherwise, it was all done manually to try to figure out how many elephants were in there. And one of the student groups, again, I can share links afterwards if you want to go read about this, and it's out on GitHub. They shared their work. They actually figured out how to automatically count the elephants in the spectrographs. Sonographs. And it's incredible, to the point where now that work can be combined with other work in that field. And so it worked. And so we're building out that idea, and we're going to put that up on our GitHub so that you or someone you know or anybody can come design a semester project or hack, a hackathon on it, whatever you want to do. But using that kind of idea, if you already know an NGO, a nonprofit, or a topic that you really like, you could just apply that. Hey, I need to learn about it. What are the use cases? And then I'm going to go hack on that for you and see if we can find you any answers. So that was really exciting. All right, now I'm going to talk about, I'm going to change, what, I don't even know what the right word, anyway, graphs. Okay, who here in the audience knows about graphs? I love graphs. I am a big fan of graphs. Many of you use social graphs. If you already know what graphs are, just bear with me for anybody who doesn't know. Graphs are a relationship first data structure. If anyone out there is a relational database person, oh, we all know too many joins. It's a disaster, right? Facebook is probably one of the, the kind of the social graph that started all of that. But LinkedIn graph, so many graphs, who you know, how you're connected to them. This is the only way and the only structure that you could really say, who's my 4th degree friend that loves, I use this example, the movie Endgame, and Beats, and went to some event, and then it can recommend people as your friends. So graphs are super interesting in that all of the recommendation engines that are out there for shopping, All of the graphs really enable a lot of cool stuff. I'm a big fan of graphs. I don't want to talk like an hour about graphs. There's a nutrition graph. I happen to be the inventor of it. And, I just use this as an example to show a different kind of graph that's not a social graph. So that is a beet connected to lessening tumor growth. So the nutrition graph was about connecting food to disease through phytochemicals and reactions in your body. And so that's a graph that I know really well. But for those of you who have been on Azure IoT and know that in the last few months, Azure Digital Twins became graph enabled. I thought that was super cool. As soon as that announced happened, I just went, oh, interesting. Because 2 years ago, I had started a project when I started Project 15, where I started putting sustainability on a graph, because that's just who I am and what I do. And I thought, why not? So there is, in the video, you're learning about Parkside Systems. I talk with my hands a lot. Oh yes, I'm in the thing. All right. So conservation systems, Parkside Systems, camera traps, sensors, collars, drones, etc. That's on the park side. But at the same time that I met Eric, I went and talked to a colleague of mine, and his name's Kirk Arthur, and he's on the justice and public safety side of Microsoft. And I said, hey, listen, I'm learning about, conservation, but I'm also, there's this anti-trafficking side of this. I mean, there are very bad people and crime, crime circles that are doing that. And I don't really know anything about catching bad guys, but Kirk does. So I went and met another scientist, and his name was Dr. Wasser over at the University of Washington. And that is a scientist whose focus is about when an elephant tusk or pangolin scale, when the materials get seized at the airports or in a shipping container. This is a scientist they would call and say, hey, where did these come from? And he does all sorts of amazing work to analyze, where these things came from once they're seized. But there's this huge gap in the middle. And it's within this gap that people get away with doing that. And so this is actually a very complicated problem to try to solve. And I like complicated problems, so why not? All right, so here is the Parkside. Here's a graph, a little graph of what's going on. So your elephant has a collar, it has a movement sensor, it falls down, the alarm, and then it sends a message. This is very IoT, transactional type of IoT. All right, here's a more complex version of it. So we still have our elephant. We have a message, the elephant fell down. I always think it's more complex, if you think about IoT and you're talking to machines in a factory and something happens, like there's a vibrating sensor or there's some sort of sensor saying it's overheating. It's very simple to talk to a machine to say, hey, you're overheating, so why don't you turn that off, kind of thing, right? The nuance to me is that an elephant collar on an elephant is actually requiring an electrical response within the elephant's biology to trigger the message. And then there's no way to go back and say, oh, get back up. That feels very complex to me, just inherently to these kinds of systems since the very beginning. So I digress. But so the elephant has fallen down and the collar has picked it up and then sent a message. Now, in the park, we have a fence. On the fence is a camera. And and here comes a poacher, human, and they're walking. And now the camera detects the human and sends an alert. And then you have an overlying system that can send an alert to the rangers, to do something. Now, there's a variable of time here. where if, let's say the elephant, now elephants cannot jump, that's a little fact about elephants, but let's say it rolled down or it laid down or something and it triggered the collar, and that happened at the same time as the camera detected a human. Well, depending on where the elephant was based on the GPS and depending on where the camera was, it would not be possible for somebody to cover that amount of distance to get to the elephant. So that may, you're dealing with that in the logic layer, and that's not an event to worry about. But if the time variable makes sense, then that is something that you need to worry about. So that's Parkside. All right. So here now we're going to add the justice side. So down here, I've got a shipping container. Let's say I have a device that can smell, and the device smells some sort of biological material, and then it sends an alarm, and then it sends a message. Okay, very standard. It's still very IoT solution-y, right? When you have both of these processes together, that's where you're starting to tell a bigger story. And the missing link, if you think about these two processes, well, I have DNA on my elephant. If you're doing a standard IoT solution, it would be very difficult to model the park. It would be very difficult to model things that are in the park, animals in the park. But on a graph, you are enabled to do this kind of complex modeling. And this is why I'm so excited about Azure Digital Twins. And I hope that makes sort of sense. But this is the thought journey that I've been on for the past 2 years. And I recently published an article on LinkedIn for this sustainability graph, animal conservation subgraph idea. And so that's I'm sure some of my arrows might be pointing the wrong way. I'm not, I've been staring at it so long, but in terms of, how do we really start to evolve, helping this area with our science. All right, I think I'm 9 minutes before the bell. I put up some links here if you want to learn more about Project 15. You can go out to that link, and the video is there, and you can also get to the open platform through that link. Or if you want to go right out to GitHub and play with the open platform, if you have any feedback, please, you can send it in. You can do issue tickets. Daisuke manages that. And he wasn't here today to speak, but maybe we can come back in the future, and you can get a deeper dive with Daisuke on the open platform. It really is really fantastic. And we've been using, actually, full disclosure, it's been helpful also for commercial solutioning. I have a colleague in Australia who was able to just spin it up, and she did a POC that had to do with trains, and she wrote me an email, and she's like, Sarah, I use this for asset tracking because, elephants or trains, it's all precious assets to whomever's tracking them. And I said, well, yes. So it was really helpful for her. So if it's always there for you to use. And that's how to find me on the Twitters and LinkedIn.